All right, we're back. We're going to be talking primarily about page 76, but page 76 relies on you knowing the fact that you can always convert from sine to cosine at the expense of changing the angle if you're willing to use cofunction identities. You can also change from cosine to sine, which actually is going to be more relevant, but you can change between cofunctions at the expense of changing the angle. So if the angle started out as 10, it's going to end up at 80 when you do 90 minus it, like that kind of thing. So we can change between them, but we'd have to change the angle to do it. We can also change between them without changing the angle if we're willing to use the Pythagorean identities, right? So sine squared plus cosine squared equals 1. We had that here. And then if you solve that, you know that that means that cosine is plus or minus the square root of 1 minus sine squared. The plus or minus is going to come from what quadrant are you in, right? So if x is a fourth quadrant angle, we know cosine should be positive, so you would choose the plus. If x is a second quadrant angle, then you know that cosine should be negative, so you will choose the minus sign. So that's what we can do. We can change between the functions. That's going to be super important. Additionally, there's some weird things we can do. So the next page, not this page, the next page, which I'm going to jump to in a second, is an insane chart that you can use to find the sine, only the sine, of anything between 0 and 45 degrees in 10-minute increments. Let me jump to that. So jump. Here we go. This is where I already tried to make this video and failed, and it was really sad. So, here's to hoping this goes better this time. I don't know. I just couldn't think my way through anything. So this is the second attempt. It happens, man. I definitely end up looking better in these videos. Well, I don't know how I end up seeming, but I seem better than I actually am because if things go really off the rails, I just start over, and that happened last time. But so here you can see, for example, if you really desperately want to know what the sine of 18 degrees 40 minutes is, it's 0.3201 approximately. So I had to round somewhere. I made this chart in Excel, and then I ended up having to screenshot it and put it into the Word document that I was working on, because every time I put in the actual chart, it just made Word crash. Like it couldn't deal with this amount of data, I guess. I don't really know why that would be the case, because I'm sure that it can deal with it, but those are the breaks. But 1840 is 0.3201, and so on. So we got everything, but we only have stuff between 0 and 45 degrees. We have nothing more. So that's going to be enough to find the value, or at least approximate it to a certain number of decimals, of the trig function of any angle at all. That's all the information that we needed. And the reason for that is twofold. So the first one is the answer to this question. Why did I only need to give you a chart from 0 to 45? Well, I can rewrite every angle. We can rewrite in terms of reference angles, right, which is like theta prime. And then reference angles, I guess you never actually get 0. Reference angles are between 0 and 90. Like they're guaranteed to be between 0 and 90. If the reference angle is between 0 and 45, we're good. We can just like use the table. If the reference angle is bigger than 45, we can then use a cofunction. So then cofunction, if necessary. Ooh, necessary? There can't be two C's, right? Necessary. I'm going to go with that. So first reference angle, then cofunction if necessary. Now the other question though is like, why only sine? And it actually could have been any trig function. It's just sine, is the one I chose. This would have been really interesting if I'd only given you like cotangents or something. That would have been terrible. But so why did I only need to give you the sine of each angle? So think of all the relationships that you know, right? You know that if you have cosine of x, you can think of it as the sine of 90 minus x. That's one option. Or you can think of it as plus or minus the square root of 1 minus the sine squared of x. Either of those work, which means that anything can be written this way, right? Because think about it. So secant is 1 over cosine, and then you can go to sine. Cosecant is 1 over sine, and then you're already at sine. Tangent is sine over cosine, but we know that we can turn cosine into sine using one of those first two things. So the only thing you actually, and then cotangent is a reciprocal. So the only thing you actually need is sine between 0 and 45. It's insane. It blows my mind that we can do this. This is one of those cool things that you can do with math that like you probably don't expect. So here, 3510 is literally in the table, right? Because 3510 is between 0 and 45, and it's already sine. So since it's already sine, it's already between 0 and 45. This is a pure lookup problem. So what are we doing? 35. I got this open on another computer so I can just like look at the problems. 3510. Let's make this smaller so it's easier to deal with. 35 is our angle, 10 degrees, 0.5760. So we go back up and say 0.5760, and that's all we got there, 0.5760. So that should approximately be the sine of 3510. All right, let's take a look at this next one. So here, the angle is not working for us because the angle is not between 0 and 45. So to deal with that, I'm going to use a cofunction identity. So I'm most concerned with the angle. Once I have the angle right, I can use my other things to get to sine. I think the most important thing is get the angle right first. So I'm going to say that this, the cosine of 5210 is going to be equal to the sine. All right, so I need to do 90 minus 5210. I guess I'll write that. 90 minus 5210. All right, what are we going to do here? So what 90 minus 53 would be 37. But I went over by too much, so it's going to be, I think, the sine of, I forget what I even said there, 50. This is going to be 30. It can't be 38, so it's got to be 37, and then 50. And what you can do, so you can do the math. I don't know why I'm avoiding that. You could do, so I'll start it out, 90 minus 52, and then 10, right? So 10 is too much. So what I'm going to do is I'm going to borrow 1. So cancel that to get 89. And then I borrowed, so now I have 60 minutes here. And then if I subtract those, I get 50 minutes. And then if I do 89 minus 52, I get 37 degrees. So 3750. I think it's easier to like intuitively just kind of like go through it, see if you can get it right. It's like a weird dog barking outside. That's weird. Now we go to the table. So I'm gonna bounce down there and then forget what I was looking for. 3750, I think. Hopefully 30. I don't remember. 30. And if you don't remember, there's nothing you can do. And also, like, I'm so distracted by the dog that's barking. 3750. Here we go. 3750 is 3750. 0.6134. Let's go back up. 0.6134. 0.6134. All right. So I might get a lot of things wrong in this strictly because I'm not super gifted at remembering numbers in my head, which, if you know me, is kind of weird, but is also definitely a fact. So let's see. The angle here, not good enough. So the first thing I'm going to do is I'm going to try to make this angle work out, right? So I'm going to cofunction. So this will be the cotangent of 90 minus 64 is like 26, but I think it's going to be 25 and then 40, right? So I basically, when you're doing these, you can almost always just immediately set them up as 89 degrees, 60 minutes minus 64 degrees, 20 minutes. And that'll give you 40, and this will give you 25, and there you go. All right, so now our problem is that cotangent is not sine, but cotangent is cosine over sine. So this will be the cosine of 2540 over the sine. I'm literally going to end this video after this problem strictly so I can go see what is making that noise outside my window. All right, so now our angles are working, and that's great. But one of them is a cosine function. So we need to change from cosine to sine without changing the angle. To do that, we use the Pythagorean identity. So the cosine of 2540 is the same as the square root of 1 minus the sine squared of 2540. And then all of that is over the sine of 2540. All right, so now if we can find the sine of 2540, we'll have an expression. And then it's kind of like well, you probably need like a 5 function calculator for this because you need square root. But let's look it up. So sine 2540, I'm going to bounce way down. 2540 is, so 2540 is going to be 0.4331. Let's go back. 0.4331, 0.4331, 0.4331. So this will be square root of 1 minus 0.4331 squared over 0.4331. Okay, and I'm just going to leave it like that because nobody's doing that by hand. So let me check these on the calculator, and then we'll see. And you'll probably be able to see on the calculator what happened to me last time is it was so sad. I did my subtraction wrong, and I got 80, and then it was like, I was so frustrated. I had, said a bunch of things that shouldn't be in an educational video, and so we had to start over. So anyway, the sine of 3510, you can see, is definitely 0.5760-ish. So that's good. Now the next thing is the cosine of 5210 is 0.6134-ish, right? It's always rounding. The next one's really big, so let's do ours first. 1 minus 0.4331 squared, because this one had by far the most steps so far. So we get 2.0812, let's say. And now I want to do the tangent, so I'm going to check tangent of, use the template for degrees, minutes, seconds, right? Second row, 64 degrees, 20 minutes, and I need a decimal, so I'm going to put a decimal point in there. 0.208, 208,094. So what'll happen is, you're using rounded values, then you're squaring the rounded values, then you're subtracting, then you're square rooting it. You're going to get more and more wrong basically every calculation that you do. So just watch out for that. Be accepting, right? 2.08 versus 2.08, very good. So to 2 decimal places, definitely right. If we were rounding, we would be right to 3 decimal places, which is all we ever really want. And at 4, it definitely falls apart. But I'm going to go back to the notes, and I'll end this video here, and I'll come back in the next one and do more of these. Some of these take a while, so I'm not sure if we'll actually finish in the next video, but maybe. So I will see you there. All right, so I'm going to stop the video, and I'm out. See ya.